Hey guys, how's it going? So today we're going to be going through text generation inference used by HuggingFace to power large language models in productions. So this stack is made up of Rust, Python, gRPC server. So it's quite interesting because I got the motivation. If we can look back in time, if you were in 2018 and you said something like you're going to deploy bid in production, you were going to get scrutinized a lot, right? Because of at that time, I feel like um, these models were quite expensive to run in production because they had very, very high latency. But the surprising thing of today is that these models, we even deploying more powerful models today in production, and we kind of like realizing this low latency also, right? So the question is, how do we then pull this one off, right? How do we do such things? So, so I'm gonna try to kind of like go line by line, try to explain, guys, what this thing does. So how I'm gonna do it is that I'm gonna try to divide this into two videos. So the first thing that we're gonna do is that we're gonna cover this first part, which is the server. Then we're gonna cover the Rust web server code in the second part. I feel like because if I want to cover each line of code, everything, so I think if I cover both in one video, then this video might be long. So I hope that's fine with you. So what are the functionalities that are included in this architecture, right? So you can think of like what they do is that they try to dynamically batch like the incoming request to increase like throughput. So those batches of requests will then be processed within this sharded model gRPC services, right? So we're gonna get into and see that how that's work. And this architecture has functionalities such as quantization with bits and bytes. It has a tensor parallelization for faster inference, and we have what we call token streaming with server-side events. So immediately, if the model generates a token, then we're gonna just send that to the client. So you can see what is happening with ChatGPT. If like you kind of like you get a response, you get like word by word. So I feel like that's what they use for they're using this technique server-side events, right? So we're gonna look into safe center weights loading, stop sequences, and log probabilities, and all of this stuff, right? So yeah, without wasting any time, guys, let's get into it. So what we're gonna do is that we're gonna start within the server. So this server here represent this gRPC service. Then this router here essentially represent this web server. Then we have a proto here, which we're gonna get into. Then in the server, what we're gonna do is that we're gonna go inside this text generation server. These are tests. Then in this text generation server, we're gonna go to the server itself. The reason I'm starting with this code is because this code references these other files, so it's gonna be much easier for us to work our way from the server. Then we can go to these other files. I think that way is much better. So but before I start with starting with this code, what I would like to do is that I would like to kind of like give you an overview of gRPC. I think that way it will be better so that you have a better understanding uh, of like how gRPC work. Because if now I try to explain the server, um, then it might not make sense how the this file structure is structured inside here because maybe it require a little bit of gRPC, right? So what I'll do instead, I'll just create a Python file inside here. We're gonna call it maybe gRPC example service, just so that like we make example, even if it's like a simple client server, it's fine. So this way, um, anyone who does not know this can actually be able to understand. So what we're gonna start with, we're gonna start with proto file, right? So just to link all of this that we're gonna do now, we're gonna link it to the source code so that we get to understand much better. So this proto file, you can think of it as like a similar thing that they did here, right? So what I'm gonna do then is that I'm gonna paste this code, which is an example, so that we get to understand how this works. So let's think that we have a proto file like so. So this is just a simple savings calculator, which is going to add two numbers, right? So the reason I'm getting these errors is because I named my file as pi and it's supposed to be proto. that's because of I wanted to do the same thing, all these stuff in the same file, but that's okay. So we have this proto file, and the main like goal or the main purpose of this proto file, essentially you can think of it as it defines the structure and the format of the messages that will be exchanged between services, right? So, and not only that, but it also defines what we call gRPC services. So these are specify the methods that will be called remotely to send data back and forth. So this is the service that I'm talking about in this case. So in this case, what we do is that we create this service, right? And it's gonna have a request and it's gonna have a response. This request is gonna have this message, which is gonna be of type int, and it's gonna take two numbers. So and these two numbers are gonna be type of int, and this response is gonna be returning an int, which is gonna be result. Then this number here, 1, 2, is just a sequence of parameters. If I was about to add another number here, I'll call it 3. So this is just the sequence of the parameters, right? So that's fine. So that's that, and this is how it works. Um, what we do is that we need to generate the code. So gRPC have to generate code for us that we can actually be able to use, right? So to generate the code, I'm just gonna paste some snippets here so that you get to understand. But so this code will be used for us work to work with, right? Because of gRPC's language and technique, so you can like literally call protobuf. So you run this code, right? And this code essentially is going to generate two files. So we can think of these two files as calculator pb2.py. So I'm just going to actually, I know what, for better understanding, I'm just going to write it down. So it's going to be calculator, right? It's going to be pb 2.py. So it's gonna generate it automatically, right? So you don't have to worry about this, but it's gonna literally generate it for you, so you don't have to worry about this. So you're gonna have calculator. Another file is gonna be calculator pb. I'm gonna explain what this does now. pb2, then it's gonna be gRPC. Then this is going to also be pi, right? So these two files, you can think of this, right? This file that is generated by GPT, it contains the message definition, right? So it contains, I'm just going to write this. So this is the message definitions that we defined right here. Then this calculator, gRPC, essentially it contains the client and the server stubs. So we're going to see how we implement those ones, right? So in a second. Then in this case, just to link what I'm explaining to the source code, in this case, in this router, not router server, essentially these files will be generated inside this PB. PB, you see here, they did not actually include them because you have to run the server for you to kind of like generate them, right? I think if I go to the make file, I'll actually be able to see there's something like this that calls the proto. Um, I'm not sure. I'm just gonna search here proto. Yeah, so this is it here. Yes, Gen. Yeah, I think this is what it's getting called. Yes, this is what generate proto. This is what I think it's getting called. But that's the same thing, right? That I'm saying here. So you're gonna generate these two files. So that's why I'm saying that they are generated automatically, and they pretty much represent what you did here. So that's fine. So now we're gonna create a new file. So this is gonna be your server. So I'm just gonna leave here. But this is gonna be a py file. So it's not gonna be in a proto. So it's gonna be in a different file. So I'm doing this so that like everything is in one code. So I'm keeping this as simple as possible so that the goal is not necessary to get into gRPC, but I want you to understand the file structure of this source code. So what we're going to do in this case is that we're going to implement the server. So I'm just going to copy this code for you guys, and then so that we get to understand how it works. I've already written it so that we can speed up this explanation. So the reason I'm not getting a highlighter, like I said, this will be a py file that you're going to create. But essentially what you're going to do is that you're going to have this class whereby you implement the logic of like the service that you defined here. So what you're going to do is that you're going to get this request, which is going to be two numbers, right? And you're gonna say request.num1. So essentially, because of you define it as num1 and num2, so you can use this. So gRPC, you already defined this. That's why you can just call them as one num and one two. You're gonna get the results and you're gonna return the results. So the result is gonna be one int value because of that's what you define in the in the in the gRPC protofile. So you might be asking yourself, but what is this, right? Like I said, that these are stubs that are generated in this file, the calculator pb2 gRPC. Then this file is going to generate your messages. Like that's why we can be able to reference them like this. So this also is generated by gRPC. Essentially, what it does, it's going to take your service name and it's going to add this thing called servicer. So then this is how you call it, right? Then you create your own server using the gRPC import. You can create number of threads, that's fine. Then you're gonna call this file, which is also coming from the calculator pbt gRPC, whereby you're gonna pass in your class and your server. Then you can start your server on a specific port, and yeah, then you can terminate for some reason, right? And you can write if name, yeah, you can write like that if name equals to main, then you call the server. That's what it is to this, right? So then your question now might be, then how does it get this one and two? That's where the client is going to come in. So you're going to have to create another file. Then this is going to be a client, right? So the client has to now give those two numbers so that it's client server, and the gRPC is the middle guy that kind of like facilitate everything, right? So also I'm just going to copy this so that we speed things up. Um, Oh, before I paste that, I just wanna, like I said, I wanna link everything that I'm saying here to the source code so that you get to understand. So you can think of the server here; it's implemented inside here. So as you can see that we're calling the same function even inside here, generate, protobuf, gRPC, and we have this text generation servicer. That's because of in the protobuf we called it text generation service, and it adds that servicer. So everything that I'm explaining is just inside here. So exactly the same, right? It's just that now I'm simplifying it so that when we get into the code, you understand in a much better way. So I'm going to paste the client. So because you're going to create a new file, you have to import these. By the way, these things, you have to import them where you have written them, by the way, right? Like I said, these are generated by gRPC. So you have to import them. So this is called, it's not necessarily calculator because we named the file gRPC example. So it's going to be that. So with this, you're going to create your channel on a specific port. Then you're going to call this gRPC pb2 gRPC. Then you're going to call this calculator stump, whereby you're going to pass the channel. Then you're going to say stump.add the calculate pb. Then you're going to add this add request, which is this because of this calculator pb2. It works with messages and types. So that's why we're calling it here, and we're passing our values num and num2, then we get the response and we can return the results. Okay, that's how it works. So yeah, I think that's fine. So that's what I wanted to explain. So now let's get into the code, right? So now getting into the code, the actual thing. So these libraries here are essentially, for those who don't know, this is SEO. So essentially we're going to use it to write asynchronous code in Python. Then we have this OS, which is going to be used for operating systems. I think we all know Torch. Then this is gRPC AIO. So I think this is a package for also writing asynchronous server and client using SEO. Then we have a logger, which will be used for logging. This is also a reflection, which is also coming from gRPC. These are like types, right? So we have this cache. What is this cache, right? So like I said, this server file is going to direct us where to go. So we're gonna now let's go to cache and try to understand what this cache does, so that when we get to this code, our life will be much easier. So I'm just going to go to cache, which is here. So what we're seeing here is that cache, it looks like it's a hash map. So this has to be a hash map, right? It's gonna cache according to this hash map. According to this, it looks like it has to cache. It has to create a cache of like what is this batch, right? Because of it is this batch, but okay. For now, we just know that okay, it has to create. It has to cache batches, but we don't know what these batches are. So it's still a question mark here. Then what we know is that we have to pop these batch, right? And we have to insert them. These are the functionality of this hash map, right? And we have to delete them, and we have to clear this batch. Okay, so that's that. But now the question might be, then what is this batch, right? So we can go to types and we can go to batch. So I'm just gonna go there and try to understand what this thing is. So we have actually server. In the server we have models. Then we're gonna go to types, which I'm gonna open here. Then I'm gonna close this model. So what we're seeing here is that we have this class, which is batch, is made up of these abstract methods. That means there has to be some sort of like subclasses that implements this, right? But for now, before we get into the subclasses, I think it's important to kind of like understand the foundation first. So what we can see is that here we have this method which is to proto, and it is to return this generate uh, p pb2 batch, right? So um, the question now is that what is this batch that he has to return? I think this is where we're gonna get some sort of like an idea what is batch, right? So what I would do is that I'll go to this, like I said, that these um, are generated by gRPC. I explained to you that, right? So I hope now you understand what they mean. So for you to know this batch, because I told you that this works with type, so you just need to go to the proto file and you will understand, because that's where we define this. So I'm gonna go to proto, and then when I get there, I'm gonna literally look for batch. So okay, this is the message. It looks like it has an ID and it has a request. And they say that this request is repeated. Interesting. So and it has the size. So this is the size of the request. Okay. So what I can conclude here is that it looks like this batch. So I think this is how you comment. So it looks like this is a batch of request, right? Not necessarily a batch. When we train like models, we create these batch from data set. But in this case, this batch is for request. That's what it is. But then the question that I have for you now is that this request, what is made up of? So let's go to this request. So it looks like this request is going to have input, which is going to be the context. So this is going to be the prompt. So it's the generation context, right? Then we have this thing called next choice and chooser, right? So I think this is going to be the parameters for sampling the next token. I think things like nucleus and temperature, I think will be will be inside here. So I'm not going to go to this now because I just want to get the foundation right? So we have the stopping criteria parameters, which will definitely define when we should stop generating the text. Okay. Then we have the ID of the request. So what I can conclude here is that essentially this batch is going to hold a batch of requests, and this is going to be the request, and this is what the request will be having, the actual parameters of the request. Does that make sense? Yes, it does. So what we can do now is that we can actually go back to the file that we came from, which is here. So what is this file? It looks like this file is going to take an object, right, of a badge, and it's going to have to send it to it's going to have to generate the protobuf file. Then we're going to say from proto, which we're going to have to take in from the proto. Yes, then we're gonna have to generate the batch object. That's what this will do. Then this is just to concatenate multiple batches, right? Then this is to return. I think this might return the length of the batch or something like that. Okay. So now let's backtrack to the cache. So what we can conclude here is that essentially it looks like this cache, uh, we're gonna create a cache, right? I'm just gonna make an example. I think we understand better with example. So we're gonna create a cache, and it looks like because of this is a hash map, so essentially it's gonna be a hash mesh or a hash map of batches. So this batch is gonna have an ID. So which means that this is gonna be the first batch, and then we're gonna have a batch like so, right? And this batch here is going to have an ID just like we saw in the proto file, right? Then it's going to be having number of requests. So it's going to be a request, and this request is going to be a list because of it has a lot of requests inside here. Okay? Is that correct? Yes, it is. So it's going to be having number of requests, and each request is going to have these inputs. So that's what I can say is that here we're going to have also like those inputs, the prompts and stuff like that. They're simply then we're gonna have the last parameter of the batch. I think is the size, which is gonna tell us the size of the batch. So this is what I can conclude from this cache, right? So now we have a good understanding of a cache. Definitely, we have a good understanding of a cache. So let's go back. Now we're gonna go inside the text generation server, all right, which is the exception interceptor. So your question will be, what does this do? So we're gonna go inside the file interceptor, which is here. I'm just gonna open it here. I'm gonna pop it here, right? So it looks like here we are handling the errors. So because we have this response that we get from passing in the request or an iterator in the context, then we get the response. If anything goes wrong, we're just gonna raise the exception, right? So I think this is how we handle exceptions in gRPC, right? So this is like the code that we're gonna use to handle exceptions, right? So this is, I think, this is self-explanatory to just handling errors. We will see how way it's getting used. Okay, so handle exceptions. That's fine. So before we get into this model, so what I would like us to do, guys, is to kind of like explain this to link what we've done so far with the architecture. So with the architecture, it looks like this Rust code is actually the guy that is responsible for batching the request. So as we said that one of the features was to dynamically batch the incoming request so that we can increase throughput. So now, which means that this Python code here, it receives a batch of requests. And then what we just did now was talk about cache, and the cache is going to be a hash map that is going to cache all of these batch. Okay, so I think I needed to explain this so that we link our explanation with the architecture. So this way we get to have a very, very good understanding of what's going on, right? So we have this model which we're going to import from this text generation models. So I'm just going to open it here from here. Where is it? Yeah, there is it here. So that we get to actually understand what's going on here. So we have this tokenizer, and we have these all special IDs, which is coming from the tokenizer, from the transformer uh, HuggingFace. Then we have this we add actually this token right inside this tokenizer as our special token. Then we generate an ID of this newly special token that we just generated. We get the length of this token decode token. Then we have this thing called this abstract method, which is going to be implemented by the subclass, which we're going to get into. But it looks like this batch class essentially is a property that is going to return the type of a batch that the model uses. Then we have this generate token, which is going to take a batch. Um, yeah, it takes a batch of input and it has to generate a list of generated text, right? And there's an optional batch. I think this is for the remaining input. I think things like concatenate might be implementing this, but we'll see. Then we have this decode token. Essentially, this decode essentially it's a function within this tokenizer. What it does is that it turns the token ID to a text. That's why here we're returning a string, something that is readable. Because of we decoding the special token ID also, so we need to remove it from the results. So we don't want this. We just want the text of the token ID. So that's what this token ID decode token does. Okay, I'm just gonna remove this model. Then that's that. What we have here is that we have this text generation service. This is our backend, right? It's like our server. So um, we all know that we specified this in the proto file. So that's why we say generate PD to gRPC, and we call this generate text generation service. Okay, so it looks like here we're gonna have this model, we're gonna have this cache, we're gonna have the server URLs. So just to kind of like link this to the architecture also, um, because of each model is running on a gRPC instance, so what's going to happen is that we have distributed the model. I think this is also because of the using tensor parallelism. Um, Check out my distributed training. I explain what the tensor parallelism is and all of these other techniques. But essentially, we distributed the model across different servers, and then each server has a URL. So what's going to happen here is that we have this list of URL as a string. Okay, and we're gonna see how that one works. Then we have these cache model server URL. Then the author here of the code state that for some reason the inference mode does not work well with Glue, which we use on CPU. So yeah, that's a problem I think they faced. Anyway, we have this service discovery. So this we can think of this as like we're trying to discover services that we have. So what do we do here? We have just to explain this with the proto. So the service discovery essentially takes in nothing, so it does not takes any input, but it has to return um, URLs, and this is repeated, so it has to return a list of URLs. Okay, so that's what it's gonna do in this case. It's just gonna return all the URLs. So we're trying to understand like all the instances of our servers. That's why I think that's why yeah have that. So that's fine. Then we have this clear cache. So this clear cache, also looking into the proto so that we understand what it does, we have this clear cache request. Essentially here we can see that the clear is going to take an ID, and this ID is going to be an ID of a batch, and we can see that it's optional, meaning that you might provide it and you might not provide it. But this cache is gonna return nothing because I'm thinking here that essentially we give it this ID because it has to remove it, right? So let's see if this is the case. We see that it says if request has a field ID, then essentially it's gonna delete this. We covered the cache in much detail, so we know that the cache is just gonna it's gonna remove this ID from the cache, okay? Else, because of this was optional, the ID was optional, then we're gonna remove it. We're gonna clear the cache. We're gonna make the cache to be empty. I hope this stuff makes sense, right? I feel like this is like self-explanatory, it's straightforward to understand, right? Um, then we have this prefill. So the prefill also has this request. I'd like to know what is inside this request. Um, so it looks like this prefill essentially is gonna it has a badge, right? So this badge is just a badge of request. So what does it do with this? So it says that it has self.model.badge type dot from protobuf. So we're requesting a badge from the proto, and we know that this method from proto, I think it has to yeah, it has to take in from the it has to take the badge from the proto, and it has to return an instance of an object of a badge, right? But we're gonna look into that now. Then we pass it the tokenizer and we pass it the model device. If we take a look at the model badge type, just wanna open the Just a second. Where is it? Is it coming from the model? There is it here. Sorry about that. So we have this batch type, right? So what I would like to do is that I would like to explain essentially this prefill using the casual large language model. I think this way it will make sense because of, like I said, that the model is just like a template. These abstract methods have to be implemented by the subclasses, and the subclasses are these models here that we see here, and the casual large language is one of them. So this here, it's gonna actually do the implementation of the stuff, right? You see here, generate, the implementation is being done here, right? So instead of us going through this, the template, I like us to go through this because now we get to understand the actual implementation, the actual thing that is going on. So this way, I want to understand what this prefill is going to do with the given batch and the token and um, the model device so that we understand what this batch is going to be returned right here. So let's get into that and see what's going on here. So referencing from the code, the prefill code, it states that self.model.batch type. If we can remember correctly, the batch type was returning the batch type, right? And then that means that this side, there has to be a method called batch type. So let's look into that. There we are. So we can see that it returned this casual large language model batch. So this language model batch inherited from the batch, right? So that means it has to have these methods called to proto from proto, right? Which is this. This is correct. So here we can see these methods that we want. So we can see that they take um, this badge. We knew about that because of that's what our request, it gives this from proto a function, right? Class method rather, and we have this tokenizer and we have this device. Okay, then we initialize this input with empty list, and we have this nose token chooser. This is going to be all of the sampling functions to sample the next token, and we have these stopping criteria, which will be all the criterias for stopping the text generation model. So then what we do here, we loop through the request, right? Just to remind you, remember that a badge that we take here is just a group of requests. So let me just remind you so that uh, you you can actually be able to see. So you can see that we have this list. I know that it's a list because it is repeated. So that means we have this bunch of requests and they're coming from the client, right? So hence here, we are actually going to be looping through all the requests. Then we take the request, we take the inputs that is coming from the request, we append it inside this inputs. Okay, we know that the request has inputs because if we go to proto, we have this request and it has this type of request. If we go to this request, because it's a type message type, it has this input, it has an ID, truncate, it has these parameters, which is for next token parameter, it has this token correct parameters. Okay, so hence here um, we're able to take that input, the context of the input, so it's the prompt, and we are pinning it within this input. Okay, then now what we do, we append these parameters. These are parameters for the next chosen choosers, right? So just to brief you what those parameters are, if we go to this node token chooser, we can see that essentially these are for sampling parameters like top P, top K, temperatures. All of these are related to how we sample uh, um, the next token, right? So that's that. But now your question might be, then what is this function? What does it do? So to understand this function, let's go to the top and see where it is imported. So we can see that it's actually coming from the utils. Okay. So what I'm gonna do now is that I'm gonna actually go to the utils, go under tokens, and I'm gonna open this, bring it closer to our casual language model, right? So just to remind you, um, so what we do now is that we try to understand what this next token chooser is gonna do, right? And I want you to understand very well. You see that we're using this from proto, right? Because these parameters are coming from proto. Remember that our badge is coming from proto, right? So these requests are coming from proto. That's why here we have to say from proto path, right? So what does this next token chooser does? So let's go to tokens and we find it. There's it here. So essentially, it takes in all the parameters, right? All the parameters that are coming from the client. So all of these things here, yes, we're gonna get them, right? I'm gonna show you how we do that. Then we have these watermark, we have these temperatures. Essentially, you can think of this as like they're being used to sample the next token. We have this sampling and we give it a seed and a device. So this sampling is defined here. So essentially, it's going to sample. Okay, we're going to take these logics, right, which will be, we're going to take this logic and we're going to convert them into probabilities. Then we sample from those probabilities given this generator. So the number of sample is going to be 1, so we return this nonce token. Does that make sense? Yes. So that's what this sampling is going to do. But then if sampling, right, if sampling is true, but else we're going to be greedy, meaning that we're going to return the best or the highest logic, like like the best token in this case. So we use this argmax, so which is gonna give us the maximum value of from the logits. So this is more like you selecting the best token, right? So just to give you a better context, usually we want to like we have things like temperatures, so that like we have more diverse creative responses from the model. So that's why we tend to tune these parameters. And if you can look at some of the applications in real world, you'll see that actually you can as the user themselves can be able to tune nucleus, all of the stuff. That's why these parameters are coming from the client. So now it's starting to make more sense. Okay, then we have the inputs, we have the input IDs, and we have the scores. So I'm thinking that the scores will be there, the logits, then the input IDs will be a batch and the sequence of tokens, I think, or tokens, yeah. Then here we check if the logit is greater than 1, then we're gonna apply this self warpers to this last logit because it's -1 here, right? That's what we do. But if it's only a single logit, meaning that the shape is not greater than 1, then we're just gonna apply it this way because that means there's only one thing inside here. So that's what we do. Then we have this. We apply the log softmax to this to these logits. Then we get the log props. Then what we do is that we have this self chooser score, which is we selected the last logits here. So which is self chooser is going to apply the sampling technique. So we get the next ID. So we're going to get the next token. Then that's when we return the next token against the log prop. Okay. So now this is the interesting part. We have this class method. So what this class method essentially is the guy that is getting called when we say from proto, because we give it this the next token parameter, right? And then what it's going to do is that it's going to return this next token chooser with all of this um, parameters that you see here. So I want to iterate to say that this function as of yet is not selecting the next token, right? It's rather going to return, um, let's go back, it's rather going to return an object, right? Remember that we're saying from proto, we are moving from proto, we are going to an object. We are going to, we are moving from proto, we are going to an object, something that we can work with. So here, we coming from proto buff and we want an object. So this we can work with. That's why we throw it inside the list. I want you to understand that, right? That's what we're doing here. That's why we're returning this next token chooser. So this essentially is all the parameters that are inside here, and there, right? So we're applying this. So we're returning this class. So we're not calling this function a Sophia. So I don't think that's what it does, a Sophia. So we're just gonna append this next token chooser. Then with the stop criteria, guys, we're doing literally the same thing that we did with the next token chooser, but in this case, we're passing the stopping parameters. So just to for you to understand this, so what we're seeing here is that we follow the same practice that we did, right? Which is that um, we have this end of token ID, we have this stop sequence criteria, we have this is, you can think of this as like the list of sentences that have to stop our model, and this is going to be the max new token. So by default, it's going to be 20. So which means that uh, we're going to stop when we reach that number of token. 20 we stop, right? That's what that means. Before I continue with this, I just want to show you that everything is in the proto, especially if we're going to say from or to proto, it has to be inside here. So even the stopping criteria, we're supposed to be getting them. um, I'm just gonna try to look for them just to make sure. Yeah, there we are. So this is the stopping criteria. So you can see that we have this max new token, stop sequences, and ignore end of word token. So if we look into this here, they supposed to be those three parameters because we say r dot stopping parameters. So if we come this side, we're gonna see that actually this is the case. We're going to be able to access these. I'll show you in a second. But this proto buff here, yeah, there we are. So this is what we're accessing here from proto ignore and stuff like that. So I was just showing you that because I want you to kind of like link all of these files that way. Anyway, let's continue. So these are all what we have. The new thing that we have here is the current token. So this is like the current token. Before we start to generate, we have this current token which is set to 0. Then the current output is going to be an empty string by default. Then what we do is that the self.current token is going to be +1 because we when we call this, we are starting to generate the token. Remember that we generate the token one by one. So what we do is that if, because we continue to generate, right, we continue to generate, if the current token is essentially greater than the self max new token, then we're gonna return true. It finished because of the length. Does that make sense? We reach the length. And similarly here, what we do is that we check if the last token equals to the self.end of token ID. Then we're gonna return that, okay, it's because of the end token. Been it's the end token, meaning that as we generate new tokens, maybe we're gonna get a new token. Okay, then this is one is quite interesting because what we're doing here, essentially we're gonna take this self output, which is an empty string, we're gonna add the last output, right? We're gonna add, because we're generating tokens, like, like as we uh, one by one. So we're gonna keep on appending to this. You can think of like tokens are gonna be added to the string. Then what we do is that we're gonna loop through the stop sentences criteria. You might be asking yourself, what is this? Essentially, the stop sentence criteria is all the sentences that are going to help us stop the sentence, right? The generation of the token. So what they do is that they use this stop sequence criteria. So what we do is that we say, given a sentence, the last token, right? Given the sen- the stop seconds, right? We want to detect the last guy. Then Um, does that make sense? Am I explaining this correctly? So we have, yeah, I think so. So we're detecting the last, given a sentence, we're detecting a last token. That's what this will do here, based on the stop sequences that we got from the client side, right? So we're gonna loop through that, and we're gonna apply this stop sequence criteria, right? Then we're gonna return true because it finished because of the stop sequences. I feel like I didn't explain this well. Let me try to repeat it. All right. I feel like I confused you there. So what we do is that we get all the sentences. Do we agree? Yes, we agree. If we go to proto, we get the sentences. It's repeated. It's a list of string. So that is fine. We understand this part, right? So which means that these are all the sentences that if we meet them while we're generating the token, we stop. Or the next word, I mean to say, because it's gonna be a text. So we're gonna stop, right? Then we apply this. So what is this? Essentially, this is gonna check given a sequence, right? It's gonna actually apply this. So we're gonna pass this sentence inside this class, right? So this is what, because we haven't called this method yet. I don't think so. So we're gonna, for each stop sequence, will be given this class, right? We have this stop sequence criterias. Okay, that's what we're gonna return. So now you can think of when we call this function, right? Because of we have this stop sequence criterias, essentially we're gonna give it the current word, the current output, I mean to say. This is where the magic start to happen. Because we give it this, then the stop sentence criteria is gonna check if what is given is gonna check the last word. Then if it's the same, then it's gonna return that it's detected, something like that. But this is what I think it's happening with us. Sorry about if I didn't explain it well. I think, but that's what I think it's trying to do. So anyway, we also append this, guys, to this stopping criteria. So then we have this max truncation, right? Which is going to be the max truncation, and we have this truncate for. I think we're going to truncate this for truncating the token, the sequence generated. We're going to look into this. Then we have this padding right offset, which is going to take the maximum value between these two. Then what we do is that we have this tokenizer. I think this is HuggingFace tokenizer, right? Because it's coming from the pre-trained tokenizer base. So we pass it the inputs, right? So we pass it the inputs. It has an S because these are all the inputs within the batch, right? Within the batch, because a batch has like number of requests and each request has like inputs. So here you can think of like you have a batch by the sequence length. That's how I the kind of like the shape of this, right? Then you have this return tensors, and we're gonna pad this. Padding, how it will work is that the longest sequence, um, then the shortest sequence will be having zeros. That's what this means, right? So that will be that. Then this tokenized input essentially is going to give us this attention mask. So this attention mask in Hugging Face, this is all the Hugging Face stuff. So you're going to have one whereby you're going to have one whereby you have like the token, but then where it's paired, you're going to be zero. So when we sum, essentially we're trying to sum all the length of each input. So this is going to be the length of each input. And when we take we're going to take the maximum length within the batch. Then we have this maximum input length. Okay, so that's what this code does. Then we have this um, tokenized inputs, which is the input ID. These are the tokens, right, of the inputs. Then we have this attention mask whereby we're gonna say input dot zeros. I think we're gonna just pet this. Um, we're gonna be pitting, yeah, we're gonna be adding zero based on the length of this maximum input length and the padding right offset, right? So I think that's that. Then what do we do? We have then we copy the tokenizer attention mask into fully allocated mask attention mask. I see that. Then here, I think here we try to calculate with this code, we try to calculate the position of the tokens in the input sequence, right? So this is going to be based on the tokenized input attention mask, right? So these positions IDs are going to be used by the model to keep track of the position of each token in the input sequence, essentially. So this cum sum function essentially is used to calculate the cumulative sum of the values along the last dimension of the attention mask um, tensor, right? So I think that's what is going to be happening. Then we return this object here. So essentially now this object here is going to be holding all of these things that we're processing. For example, the where is this? I think the inputs or all of the stuff, right? So we have the position ID, the attention mask, the input IDs, which is going to be the tokens. The past keys is none because we are not generating anything here. We haven't generated the next token. We just like have these nose token choosers. I think what this is all the necessary components that we're going to need to generate the next token. So now, if we backtrack, we do understand what this batch is. Is this thing here, all of this stuff here. So the batch ID, the next token function, the sampling functions, the input lengths, all of these guys, right? This is quite interesting. So now, the interesting thing is that if we have this batch is not a protobuf. It's literally coming, it's like a Python batch. You can think of it that way, right? So because of the from, it essentially takes from proto and it's going to return like an object. So that's what I think of it, right? So now we take this, we pass it inside this generate token. This is what I think is going to generate the next token because now we gave it uh, all of those inputs. It has the tokens. It has all the information it need. It just need to run the those inside the model. Quite interesting to see that now things are starting to look much clearer. So let's try to understand this generate token now. So going into the casual language model file, we're gonna have to look for the generate function, and I think it should be here. This is what we have. So we expected this. We know that it takes in the batch because of that's what we gave it here. So what does it do with this batch? So essentially, it called this model self.forward. So you can think of this as a model. So because of these model are autoregressive, like GPT, essentially they have these past key values. And this model is coming from the Hugging Face because we can see it is auto model for casual large language model that from pre-trained, right? And we have the model ID here. So, what this model is going to retrieve is going to retrieve the logits and the past keys. Then, um, given that we also have these next batch keep indices, so using these lot of next batch length, next batch input IDs, essentially you can think of these as like we're gonna have to go through for each member of the batch, right? We're gonna have to loop through so that we can generate the next token. But not we're not gonna finish for all the batches, right? So what we're gonna do is that we're gonna then for those ones that we did not finish them to generate the token, we store them inside this next batch keep indices. So you can think of this, it's gonna keep track of like this the batch that we did not complete and they need to be completed, then we're gonna store them inside this next batch caches, right? That's what we can think of this for now, but we're gonna get into it, and you're gonna see how it's getting implemented anyway. So we have this generation here. So you can think of generation as like the generated text, right? That's the something that we have to return. So it's gonna be a list because we have to store the generation for the batch. Then we have this iterator in this, whereby we store the batch request, the input length, and the logit. And for each member of the batch, so meaning that we have this, we have these batches. Then for each member of the batch, we have to generate the new token ID. All right, I hope that makes sense. Then we call this node next token chooser. Essentially, if you can remember this, it was this next, where is it? It was this next um, token chosen. So like I said, that we were not calling these methods, rather we were just like having some sort of like a template that we can call them. So we can see that it takes in the input IDs and the logit, and which is this case, we can see that we give it the input and the logit. It has to give us the next token ID because it is a sampler. It samples given the logit, right? And it returns these log probabilities. Okay, then we have this all input IDs and the next token ID. So we append with this next token ID to these all input logits, right? So then we increment the length. The new input length is going to be input length plus one. So the intuition behind this code, we can think of it as like, because of these models auto-regressive, like you have to use the previous values to generate the next token. So it's gonna literally keep also the next token as like they're gonna become previous, right? That's how I think of it. Then we have this generated token, which is going to be the next token lock prop. Then we have this next token squeezed. Then we're gonna try to decode this next token ID to the text, because now we have to write it. Um, because now it's a text, we have this stopping criteria in which we're gonna pass this next token text. So we know that this stopping criteria essentially is gonna check if like this next token that has been generated, it is the stopping criteria. By stopping criteria, I mean it it meets these requirements. It is greater than the max new token. It is this end of the token, or it has this. It matches these sequence criterias. That's what I mean here. And this is if this is true, right? Because it returned true. Just for your reference, it has to return true, else it's going to return false. That means that it's not supposed to stop. It's supposed to continue generating in this case. But let's just assume that it's true. So what are we going to do if it's true? Essentially, we're going to have to get the output text by going all inside our all the input IDs. We're going to have to extract um, using the current token. Then we're going to get the output text. Then we're gonna have this generated text, meaning that we're gonna pass this towards the generated text. I think this is is coming from the tokens. If just to show you where it's coming from, I just want you to understand. Okay, it's coming from the types. So we essentially we sending this to Proto. That's what we're doing here with the generated text. But I just want to show you. So it is generated text. Okay, yes, it is generated text. So yeah, there's it here. So you can see we're taking the text, which is a string, because we decoded the tokens, and then we have this to protobuf, right? We're gonna send it there. So that's what this is gonna do essentially, right? And then this is what we generated. So here we're done with generating the the output text. That's what that means. But let's assume that we are not done. Let's just assume that we are not done. For some reason, we still need to continue to generate the next token. Then this code here will run. So essentially we have to keep the request in the batch, and this is what the next batch keeps track of. It keeps the guys who are not done. So it's gonna like append the ith element because we're iterating through. It's gonna keep the next token ID. It's gonna keep all the input IDs, and it's gonna say the next batch size is gonna be +1. So it's gonna keep everything. So you might be asking yourself, but what's the intuition behind this? The intuition behind this essentially is that um, if if there is a batch, we finished it, right? We're not gonna increment this. The next batch size, we're not gonna increment it, right? So which means that we're gonna have a code. Yes, we're gonna have a code to check the next batch index. If the next batch index is not equals to the batch size, then we know that we have, for some reason, we have completed something. Something has been completed. But if it's the same, then we have not completed. Then we have to continue to we have to push this batch and go and generate the finish it, right? That's what I mean here. Then we have this prefill, right? Before, just to give you like some sort of like a high level of understanding of prefill. So because of we working with these auto-regressive models, so essentially you need some sort of like a previous tokens for you to generate the next token. But now what happens when the current token is the first one? So it does not have the previous token. So so this code retrieve the previous tokens, right? They retrieve the prefill tokens and their corresponding lock probabilities from the input sequence to use as the starting point of the generation. So what it does here is that it gonna put a float of NN at the starting point, like the first prompt token. Then it's gonna gather um, um, it's going to gather all of these. I think it's going to extract the log probabilities of the remaining tokens in the input sequence, right? That's what that getter will do. Then we have these, what is it, the prefill token IDs. Then here we're just going to extract the, the new input length. So it's going to be the prefill tokens, like the input sequence, because we need to pass it here. Okay, then we have this self tokenizer based decoder because we're gonna have, then we decode these tokens to get a text. Then we have this prefill token and we pass them inside here. Okay, these are our prefill tokens. So but the intuition behind this code, essentially, if I might have confused you there, essentially you can think of it as like we're trying to kind of like use the input sequence as like the the that's some sort of like an input, right, to the model, because of it has to use the previous context to generate the new token. So that's why we push it. We have this prefill tokens, which if I go to the type, we can see that it's also going to send this to the protobuf. So that's what it's going to do, is taking all of these stuff that we provided with. Else we're going to use null because we already have the previous context. We don't we don't this only happens when like we're starting out. So I feel like that's that. Then we have this generation. We call this generation with these request IDs, and we're gonna pass in the generated text to this generation, right? So this generation text is gonna be coming from here, okay? And it's going to be coming from generated text. Here it's going to be none, but in this case it's going to be a text that has been generated, because here we are done. Here we set it to none because we are not done. Okay, and this generation essentially is also coming from the type. Essentially is going to send this to the protobuf. Okay, that's what we do. Then what we do is that we append our generation to this generations. Okay, so that's what I think it will do here. So yeah, for each member of the batch, we're gonna generate the token. So you can think of like for each batch, we generate the next token, we go to the next batch, we generate the next token, just like that. Um, yeah. Then it's possible that definitely um, we might have not finished. If we did finish, the next batch keep indexes, then we're gonna return the generation and we're gonna return this none. And this, if we go back to the 7, we expecting to get the generation and the next batch. So here we don't have to return the next batch because we're done. That's why this next batch is optional if we go to the type, actually not type, but proto. Um, I forgot actually where I saw it, but it was optional. I think it's here. No, it's yeah, I'm not sure, but anyway, but yeah, I think it's in the proto, but it's definitely something that is optional. Anyway, that's fine. Then the authors state that if we finish at least one generation, we need to evict the indices of the generation that finish from the values. Yes, it makes sense. This is the same thing that I was talking about. Is that if we finished this because we finished that, right? We need to evict it from uh, uh, um, the next batch keep indices, I think, and this code will implement that. Else, we just need to keep everything because of that means none of these are done. Then we going to return this casual. This next batch is going to be the casual language model batch, which we're going to return as the next batch and the generation. So this will need to be implemented, right? So again, because it has to complete. That's what I think this is going to do. Okay. Um, yeah, I think that's that with this generation function. And what do we do here? After we have returned this, we cache this next generation. We use the cache to cache it. Then we call this return. Then we say generate prefill response, right? Because of we need to, yeah, we're sending the response. That's when we saw it. Then we're gonna say for generation in generations, then we're gonna say generation to proto, which you're gonna get the generations. Then similarly, batch is gonna be next batch to proto. If batch, else is gonna be none because this next batch is it's gonna be optional. So that's like the prefill. Um, the prefill logic. I hope you guys actually were able to understand it. There are certain things that we might actually come back and try to understand in a much better way. But anyway, let's continue. So we have this decode async function. So it has this request. So we're getting a batch. So we just need to make sure that there is a batch within our request. But it looks like this is actually a list of batch. So just to make sure, decode request, yes, it's repeated. So we have like a list of batches, right? Then what we do is that we're gonna get a batch in which we're going to pop it out from the cache. Then we take this batch and we append it within this batch list. Okay. Then what we do is that we check if the length of batches, meaning that the batches that we have appended inside this list is greater than 1. If it is, we will call this concatenate method from the casual lm.py file. Otherwise, we're just gonna take the first batch because of that's the only batch that is within, right? So I just want to make sense out of this. So when we go through this decode, so it looks like essentially because within this prefill we cached the next batch, right? We set self.cache the next batch, and it looks like we're gonna get the cached batch with this decode method because of that's the time we popping them out and we have to append them inside here. So what I can say is that it looks like this function, this decode, essentially is going to get all of these next bits that were not completed, and it's going to try to concatenate them so that we can complete them. Okay, so this is how I'm interpreting this, right? I'm not 100% sure, but this is how I'm interpreting this. I feel like this prefill essentially is going to be the first, um, when the user make the request, is going to be the first one that gets called, because it has to for the first next token, we have to use the request prompt text, right? Itself is like the to prefill, they are auto-regressive, like I said. Then we then after we have done that, we're gonna use this decode so that we can be able to complete these next batches that have not been completed. Um, right? So we'll see actually where this how this works. But now, as much as I said, guys, we following the code path. So in this case, it looks like the code want us to go here to this batch type concatenate. So how do we concatenate these batches, right? Um, just gonna scroll up. So yeah, I think we've pretty much finished this code, this side. I feel like this casual language model was like the heavy part of things, but yeah, we managed to. Okay, so I'm not gonna go too much into this. I feel like it's straightforward in such a way that we're just trying to concatenate, and we're gonna just return the same instance, but this time we have concatenated all the batches. So that means that the pass key values, the mask attention, the input, all of these things have been the max input length. Now it takes into consideration all the concatenated batches, right? That's what I feel like this concatenate will do in this case. That's why here we have to look through all these batches. Then what we're gonna do in this case is that we have this batch, so we can think of it as a one batch, right? Even if we have concatenated them, but we can think them as a one batch, because now we're gonna pass them through this generate token. We covered this thoroughly when we went through the prefill async function. So we know that this is going to return the generation, and it's going to return the next batch. So we're going to cache all those that have not been completed inside this cache. Okay, then we generate protobuf, which is the decode response. Then we return the generation and the batch. So that's what this decode will do by the look of things. Okay, so now I just want to cover the server so that we understand uh, how it works. So looking now into the server, um, so this is still in the server.py file. So essentially we have this model ID, which is going to become is going to represent the ID of the language model to use for generation. Similarly, the revision is going to be the revision of the language model. Then sharded and contours are bool because they can be true or false if we should shard our model or contours it or not. Then we have this UDS path, which we can think of it's a path object representing the Unix domain socket path for the server. Then if sharded, we're gonna server URLs, we're gonna get the server URLs and the local URL from this environment variable called rank. Else, we don't have to shard the model. We're just gonna use this Unix socket template, um, and then we're gonna get the server URL. Uh, we're gonna assign the server URL to this list of local URL. Then we're gonna call this get method. I think this is just a function to call a model from HuggingFace given the model ID. Else, then it's just gonna raise an error that it can initialize the model. Then we have this server IO. So we can think of this as the service being created as an asynchronous context manager. Essentially, it uses these two interceptors to handle exceptions. I think we went through this when we we started the program. Um, then we have this generate protobuf to gRPC. Then we call this. Then we pass in this text generation service with the model, the cache, and the server URLs, just like we did here. So this is what we did. Did then where we were, yeah, we were here. Then we pass in also the server inside here. Then we have these reflections, right? The server uses their reflection to enable the introspection of its services. So this means simple means that client can use gRPC reflection to decover services. All right, that's what that means. Then we have this. The server is gonna start. Server that wait for termination. It's server start. Then we're gonna have to wait for the termination here if like there's a keyboard interruption. But anyway, that's all it is to this. Then we have this. We're running the model based on those parameters. But yeah, that's all it is to this, guys. I'm gonna create part two. This was part one. I think part two is gonna be much more interesting. Yeah, we're gonna cover the Rust code and see. I think this is gonna be cool. I wanna understand how the batching work, and all of this stuff, right? So it's gonna be quite interesting to see all of this and try to understand how you create a batch, all of this cool stuff, right? So it's gonna be interesting. But yeah, I wanna say thanks, guys, for tuning in.